Okay, let's get started. Hello, everyone. Welcome to JuiceFS CSI. That's the graphic. Thank you. Um, okay. So happy China New Year. I hope you have a wonderful holiday. So this is our seventh episode of JuiceFS Office Hour. So today's topic will continue your favorite one, the CSI driver. So today's session will cover the common issues, troubleshooting methods, such as the storage mount failures, performance troubleshooting, and how to pinpoint the root cause, checking the logs, and also using the monitoring tools to measure the CSI driver performance. And for today's session, we welcome Joseph engineer Yifu to go through all these troubleshooting methods. Before we doing that, I'd like to announce some community news. So for the JuiceFS community edition, we have a new version coming out, which will optimize the bench deleting, enhance the cache scanning, improved and added new metric, so you have more visibility of the performance. And for the CSI driver itself, we have a dual version, which add the functionality like the data snapshots and introduce a new health editor called volume path, and also add a sample dashboard for the CSI monitoring. So that's the community release news. And without further ado, let's welcome Yifu. Yifu, it's all yours.
Yeah, thank you. Hi, everyone. My name is Liu Yifu, and I'm here to talk about CSI dashboard and how we can use it to do performance tuning and overall troubleshooting the mount port. Okay. So the reason that the CSI dashboard is so useful is that it visualizes everything in the web UI here. Before we have CSI dashboard, everything is pretty much manual. So the most difficult part of troubleshooting, in my opinion, is actually finding the right mount pod for your application pod. Okay, so here you can see that I have just one application pod using a JuiceFS PVC. So in my test environment, I only have one mount pod, which does not create much confusion here. But in a real production environment, we can have many application pods. And ideally, if you do not change any mount configurations and you do not upgrade our mount image at all, the mount pod can be reused, shared across the same PVC. So all the application pods which are using the same PVC on the same node, they will access the same mount port. Okay, but the thing is, you can have many PVCs and you can change the mount configurations and pod resource definitions, and you might upgrade our JuiceFS client, that is the mount image. And if you do this configuration changes, the new mount pods are going to be created in order to apply the new configurations. So that's when you can have many more mount pods and you do not know which mount pod is actually serving your application pod. Okay. So now we already have the dashboard installed, and I have opened the web UI. You can see clearly that every pod and its associated mount pod is listed on the table here. Assuming that you do not have CSI dashboard installed, I'm going to show you actually how to find the right mount pod for the application pod, and just to show you how troublesome that is if we do not have the web UI to do this. So my application pod is installed, I believe, in the default namespace here, which is called JuiceFS app. Yes, that's the one. And first of all, we're going to get its UID here. Okay, so every pod has a UID field somewhere in its YAML definition. Okay, we're going to copy this UID. For the sake of simplicity, I'm just going to use the last part here. And then I have composed a useful command that prints all the mount pod names and its annotations here. Okay, because the UID is going to be inserted in the mount pod metadata under the annotations field. Okay, so if we can get all the mount pod and print its annotation, we can search for the UID in all the annotation content to help us identify which mount pod is actually serving our JuiceFS application pod. Okay, so let's print out everything first, since we only have one. Okay, we only have one, so everything is pretty much the most simple. And we can see that there is a field called JuiceFS dash some random string here, and its value, it do not have the value. We can just grab the UUID. Okay, you can see it's printed out here. So that's how we find the relationship between an application pod and the mount pod. So we know that this pod here is serving our JuiceFS app. Okay. So just imagine that we have a lot of mount pods and we're actually searching for the UID inside that huge content here. Okay, so now we just navigate back to the web UI, and you can see that I can click on the mount pods to see everything related to it. We have the YAML definition here. You can check out the actual full mount command in the pod definition here. Okay. And since I'm using the latest version of our CSI dashboard, it actually introduces many new features that helps a lot in performance tuning and troubleshooting, which I will briefly cover later on. We have the stats button here. Okay, we can click on it, and it's going to introduce JuiceFS stats, this subcommand here. It can print all the performance metrics in real time, refresh every second. So it's better than checking out these metrics on our JuiceFS web console in the monitoring tab. Okay, the standard monitoring scraping interval is 30 seconds, so it might not be helpful if you have performance issues that lasts a very short period of time. Okay, and we can click on the log button to see the mount pod logs here, so you don't have to carry out any more manual kube control commands. Okay. So that's the basics. That's how we can use dashboard to find the right mount pod. And if you have any questions regarding the basics, you can post them now. So next up, we are going to assume we have some mount pod issues, and we're going to debug. Okay, as I've shown just now, we if this mount pod crashes or hits any sort of error. I mean, if you're accessing a JuiceFS file and it raise an error called something like input output error, and to troubleshoot this kind of error, we need to find the mount pod that's serving the file system and click the log button. Every input output error will have its error logs printed out in the JuiceFS client output. Okay, so you can check the logs to see why it's hitting an error, and the part before the error will most likely be the cause. For example, you can have network issues, which may abrupt the connection between the JuiceFS client and metadata, or JuiceFS client and object storage service. Okay, check the logs here to see why it's hitting the file system error. Okay, and there's another likely scenario where the mount pod isn't created at all. So if we do not have a mount pod created, and the application pod will simply get stuck in the pending phase, I believe. So when this happens, the component that's responsible for creating the mount pod is to be investigated. So we're going to check the logs of the CSI node here. Okay, I'm going to use this command with this label selection to find out all the JuiceFS CSI components. Going to print out its node name as well. So for example, if your application pod is created on the first node here, 001, okay? Created on the first node, and somehow the mount pod isn't firing up. In this case, you're going to check the logs of our CSI node here. So you can do control logs to see what's happening here. Okay, so it's most helpful if you can extract the logs of CSI node on which your application pod is creating. Okay. And you can also do this by navigating to the system pod page here, and click on the CSI node on the first Kubernetes worker node here. And the same can be done by clicking the log button. You can see there's 3 containers here. The one we're looking for is the JuiceFS plugin. Okay, this is the part where we'll put all the actual work inside. The other 2, Liveness probe and node driver registrar, is just standard Kubernetes components. It's not related to CSI driver application logic. Okay, so if the mount pod does not create, you can check the CSI node logs here to see what could potentially be wrong. And if you ever need to debug JuiceFS authentication errors, I mean, if your environment has some kind of network issues that prevents JuiceFS client to authenticate with our web console, you can open up a interactive session inside the JuiceFS node here, and see if we have the JuiceFS client installed. So here we have the JuiceFS community version here, which is located under this path. And we also have another JuiceFS client installed under user bin, so you can actually use user bin JuiceFS for the JuiceFS Enterprise edition. Okay, so for community users and enterprise users, you should use the respective JuiceFS version. And we can run some authentication commands like JuiceOS my JFS here. I'm not going to hit the command since it's an imaginary one. Okay, you can test the authentication process in the container to see if you have any network issues. And next up, we're going to do some simple performance tuning stuff. Inside the mount pod page in the dashboard web UI, you can use a lot of the features introduced in recent CSI dashboard versions. We also have access log here, so you can see all the input, output. I mean, all the fuse requests initiated by this mount point. Okay, so you can see my application pod here is constantly writing and uploading stuff to the object storage and release that file, and do the whole process again and again in the out.txt file. Okay, you can use this log to find out what the application is doing. So when you hit any strange errors, you can send that to the to us, to data engineer, and we will help you find out what could be potentially wrong. Another useful thing is the JuiceFS stats button here. This is actually just the same as the JuiceFS stats command. It's just in the web UI we run the command for you. So if you're not familiar with it, you can just hit the start button here. It's going to print out everything nicely in this text field. We're not using distributed cache, so I have disabled this column here. And from left to right, we have all the basic usage here. We have CPU, memory, and JuiceFS buffer usage, and cache usage here. For example, if this buffer section is really high, and you may consider to increase the buffer size mount option. And we have fuse traffic here. Pay attention to the read and write field. The read column are all zeros. This is because we're not actually reading anything. We're just appending text to an existing file. So it's constantly writing small content and upload to the object storage. As you can see, it's the same number across the fuse section here, and the block cache, and also the object storage. When you're dealing with performance issues, it's usually the some part of the data flow is very slow. So you may want to check the LAT part, which stands for latency. Okay, you're going to see going to examine the latency in each section here. For example, if you have poor connection between the mount point and object storage, then the object storage latency is going to get very high, which can be reflected here. And suppose we have remote cache enabled. That is the distributed caching in our system. We can print out the remote cache sections as well. Let's wait a bit to wait a bit for the table title to appear. Oh, here it is. So if we are using remote cache, okay, then we can see its read and write traffic here. And we can troubleshoot remote cache latencies by looking at the LAT column here. Okay, since we're not since we only have one client in the test environment today, so we don't have any remote cache metrics data. And if this is not enough, you can enter the mount pod to open up a interactive terminal here, and use df -h to find out our mount point. We're going to navigate to this directory, and we can also manually run JuiceFS profile command. Okay, so this command counts all the matrix numbers and aggregate them to visualize the overall costs on some specific file operations. Okay, you can let it run for a few seconds if the file system load is very high, and you can see the time used by each type of fuse operation here. Okay, so that's JuiceFS stats and JuiceFS profile. Bug. And there's another command called JuiceFS debug, which collects information under the mount point, and it also extracts some of our important Golang troubleshooting information here. And you can use the debug button here to do that. But the output it's going to compress everything into a tarball, and usually you just send the tarball to data engineer to help you for with the rest of the troubleshoot. And that sums up today's session. I think that's pretty much it. Thank you, Jianxing.
So this is the Q&A time. So feel free to post your questions or things you want to discuss, either in the YouTube channel or our Slack channel. And make sure you follow our linking profile, or the GitHub repo if you like it. Make a start. And if you want to contribute, you're welcome to create PR to the repo. As currently it's exceeding 1,300 stars now, and it's growing community. So I hope this open source project will bring value to your either your company or your personal project. Okay. So let's give you a few for you guys to have questions. Okay. So it's conclude today's session. Thank you for watching. See you next time. Take care. Bye bye.